There are different ways to make a buffer. In the previous video, we saw where we added a weak acid and its conjugate base, or we added a weak base and its conjugate acid, which we did in these two final cases here. It is also possible to form a buffer by partially neutralizing a weak acid or weak base. So in this case, we're going to react hydrofluoric acid plus sodium hydroxide. The sodium hydroxide, of course, will dissociate into sodium and hydroxide ions. We'll produce water, and then we'll produce fluoride ions. So if we have, at the end of the reaction, if we have hydrofluoric acid and fluoride ions present, we'll have a buffer. If we don't have one of them present, we don't have a buffer. So it says here that we've got 0.10 molar hydrofluoric acid and we're adding equal volumes. So we can determine that the number of moles will be in the ratio of 0.10, and then it says 0.05 molar hydroxide. We start off with fluoride ions of 0. So what is going to happen? Well, the hydroxide ions are going to completely react with the hydrofluoric acid, but you can see I only have half as much of my strong base. So the hydroxide is going to get completely used up. I will have some hydrofluoric acid left over at the end. And if you look at the fluoride side, all of the hydroxide that reacted with half of the hydrofluoric acid formed sodium fluoride, or in this case, just the fluoride ions I show. So at the end, we have 0.05 moles of hydrofluoric acid and 0.05 moles of fluoride ions. So at the end of the reaction, we've got fluoride ions and hydrofluoric acid molecules, and then the sodium's a spectator ion. So the fluoride would react with incoming hydrogen, so that would be half the buffer, and the hydrofluoric acid would react with the hydroxide. So yes, we have a particle that will react with incoming hydrogen and incoming hydroxide. Well, let's take a look at this case at the bottom. So let's take the same reaction. All right, in this case, our initial concentration is 0.10 molar for the hydroxide and 0.05 for the acid, and of course 0 for the fluoride. What will we have at the end? Well, in this case, the hydrofluoric acid is the limiting reagent. In the previous case, hydroxide was the limiting reagent. So at the end, we'll end up with the same amount of fluoride as we did previously, but the hydrofluoric acid will be gone, and we'll have excess hydroxide ions, which is a strong base. So what we'll have present is sodium, we'll have fluoride, sodium's our spectator, and our hydroxide. Well, we're not going to have hydroxide ions and it be a buffer. So the answer is no. There's no particle in here that would react with hydroxide. And if we added hydrogen, it would react with the hydroxide and that would change the pH. So we cannot have hydroxide in our buffer. Okay, in this case, sodium monohydrogen oxalate, is it a buffer? Well, our particles present are sodium and the monohydrogen oxalate ion. If I add this, I add hydrogen to that, I form the weak acid, oxalic acid. And if I add hydroxide, I form water and the oxalate ion. So this turns out to be a buffer. Even though it's one particle that reacts with both the hydroxide and the hydrogen, it is a buffer.